Hi there, and thanks for tuning in. Today we're going to be looking at 3.2 Part 1, linear functions, and we're basically just going to be identifying which ones are linear and which ones are not. Today's notes are going to have 9 things written down, so let's go ahead and get started. The first thing we want to know is just to make sure what are linear equations and linear functions, okay? First thing you're going to see is a linear equation is an equation that can be written in the form of y equals mx plus b. This is going to be coming up as well. This is called slope-intercept form later on in this chapter, so it's very important that you know that is going to represent a linear equation, and m and b are going to be constants. So they're going to be basically numbers. A linear function is a function whose graph is a non-vertical line, so anything that's not vertical, which means straight up and down, and it can be represented by the linear equation as shown above. A nonlinear function doesn't have a constant rate of change, which means its graph is not a line. Okay, so we're going to take some time here to just pause the video and write the 3 vocabulary words down and their terms or definitions, and then once you're done, click play to see how to identify a linear function. So one other thing I wanted to show you here is you can represent linear functions in multiple ways. One way is you can write it in words, and output is 3 more than the input. You can write it as the equation. Remember, the equation should look like this or be able to be solved for y, where you have mx plus b, where m and b are constants. You can also show them in input and output tables. Mapping diagram, that's just basically showing one input for every output. And then your main important one here is your graph, noticing that it is a straight line. Let's go ahead and pause the video here so you can write down mainly your standard form and your graph. If you want to write down the other things too, you can. Alright, so what we're going to do here is just identify which ones are linear function and which ones are not. Okay, so just keep in mind linear functions have to have a line. So in letter A, we're going to call this one non-linear because it's not a line. And that means there's no constant rate of change. However, letter B is a line, so that one would be linear because it is a line, which means there is a constant rate of change. Okay, so it's basically what you're writing and identifying. Either it has a line, so it's linear, or it doesn't have a line, so it's nonlinear. And remember, when it does have a line, that means it has a constant rate of change. Okay, and that's what we want for linear functions. So here are 3 and 4 that you're going to try. Let's go ahead and pause the video here so you can try them, and then once you're done, click play. So number 3 is linear because there's a line, which means constant rate of change. But for number 4, it is a line, but there's no constant rate of change. This is nonlinear because no constant rate of change. Okay. The next part we're going to look at is when we're looking at a table. Okay. So this table here, we can look to see that it's growing by +3 on the top, and it's decreasing by -6 on the bottom. So each one is being added or subtracted consistently. So we're going to say that letter A is linear because it's consistently or a constant rate of change. But when we look over here, I can see the top row is growing by 2, but the bottom row, this one's +7, this one's +11, this one's +15. This one would be nonlinear because no constant rate of change. Okay, And just keep in mind, you can only add or subtract here whenever you're focusing on linear functions. If it was multiplying or dividing, that would not be considered a linear function. Okay, so only addition or subtraction for there. So here are two that you're going to try. Let's go ahead and pause the video so you can try 5 and 6. And once you're done, click play to check your work. So number 5 is linear. Because there is a consistent rate of change, we are adding 1 up here, and on the bottom we are adding 2. Okay, if you notice for number 6 though, we're adding 1 on the top, but we are subtracting 8, subtracting 4, subtracting 2. So number 6 would not be linear. So that would be nonlinear for number 6 because you're not consistently changing there. The next part we're going to look at is just represents the following equations representing linear functions. And remember, a linear equation has to be written in the form of y is equal to mx plus b, where m and b are constants. Okay? So right off the bat, you should be able to say that this one is not a linear function, and neither is this one down here because they have exponents and square roots. Okay? If we look over here, notice that x squared is happening, and x has to be a single exponent, so that one's not going to work either. So we're basically down to 3. For this one up here, y is equal to 3.8. Technically, that one can be written as this: y is equal to 0x plus 3.8. And so because it can be written as that equation, the standard form, we would say that this one is considered a linear function. For this one down here, if you distributed the 6, you'd get y is equal to 6x minus 6, and so this one would also be considered a linear function. This one over here has y by itself, but x, it's not showing m times x plus b, so this one would not be considered a linear function because it's not withholding, or you can't solve it to where y equals mx plus b. Okay, so there's only 2 right here that can be represented as linear functions. So you're going to try these last 3, and just to identify which ones can be written as linear and which ones can be written as nonlinear. So let's go ahead and pause the video here so you can try it. Remember, they should be able to be written as y is equal to mx plus b in order to show a linear function. Alright, so number 7 is clearly linear. Here's your m and here's your b. Okay, for number 8, that one was not as clear, but you do notice that you could have 3, maybe rewritten as 3/5 x. And then remember, b is just another constant, so you could actually add plus 0. So this one can be rewritten as y is equal to mx plus b, so we would also say that this one would be linear. For number 9 though, notice you have an exponent of 2 for the x, and there's no way to get rid of it with using square roots, so we would say that this would be non-linear. Okay, so that is going to conclude our notes for today. Just make sure you have those 9 things written down. Thanks so much for tuning in, and we'll catch you next time.